Good morning everyone. I am warmly welcome you all to today's session. I am Femin George, Assistant Professor in Nehru Arts and Science College. In this session, we are going to discussing about Chapter 17, Fundamentals of Digital Device Security. The objectives are the basic concepts and importance of digital device security. The CIA triads means confidentiality, integrity and availability. Difference between authentication and authorization. About encryption, firewall and antivirus protection. Cybersecurity best practices and device security policies. Basic security measures to protect digital devices and information. So what exactly is digital device security? Digital device security refers to protecting digital devices such as computer, laptop, smartphone, tablet, servers, storage devices and IoT devices from unauthorized access, malware, cyber security, data theft and physical damage. The main purpose is to ensure that only authorized users can access the device and that the information stored on it remain safe. Now let's look at the objectives of digital device security. The first objective is protect confidential information. This means preventing unauthorized people from accessing sensitive data. For example, only you should be able to access your personal email accounts. The second objective is ensure data integrity. This means the information should be remain accurate and should not be modified without permission. For example, no one should be able to change your examination marks. The third objective is maintain availability. Information and services should be always be available when needed. For instance, an online banking service should be accessible whenever customers want to perform transaction. The fourth objective is prevent cyber attacks such as viruses, ransomware, phishing and hacking attempts. Finally, ensure user privacy, which means protecting personal and organizational information from misuse. Importance of digital device security. Now let's understand why digital device security is so important. Organizations store huge amount of confidential information digitally. If these systems are not secure, hackers may steal customer information, financial record or business data. Digital device security helps to protect sensitive information, reduce financial and reputational losses, ensure business continuity, meet legal and regulatory requirements, protect against emerging cyber threats. For example, if a hospital's computer system is attacked by ransomware, doctors may lose access to patient record, which could affect patient care. Therefore, securing digital device is essential. CIA triad. The CIA triad is one of the most fundamental concepts in cybersecurity. It stands for confidentiality, integrity, availability. These are the three goals of information security. Let's discuss each one detailedly. Confidentiality means keeping information secret from unauthorized users. For example, your ATM pin should only be known to you. We achieve confidentiality using password, encryption and access control. Next one is integrity. Integrity ensures that information remain accurate and unchanged. Imagine if someone changed your semester marks card in the college database without permission, that would be violate data integrity. Organization use hashing, digital signature and audit logs to maintain integrity. The final one is availability. Availability means authorized users should be able to access information whenever they need it. To ensure availability, organizations use backup and disaster recovery plans. Now, let's look at some practical examples. For confidentiality, online banking applications encrypt customers' information so that hackers cannot read sensitive financial data. For integrity, when you download software, the developers often provide a hash value. If the downloaded file has been modified, the hash value changes, indicating that the file may be tampered with. For availability, cloud service providers such as Google and Microsoft maintain multiple data centers. If one server fails, another server continues providing services without interruption. These examples show how the CAA triad is applicable in real-world system. Authentication. Authentication is the process of verifying the identity of a user before granting access. Authentication answers the question, who are you? For example, when you are logging into your Gmail account using your username and password, Gmail verifies your identity. These are the different authentication factors. The first is something you know, such as password or PIN. The second is something you have, such as smartphone or security token. The third is something you are, such as fingerprint or face. The fourth one is something you do, such as your typing pattern. The fifth one is somewhere you are, where your location is verified using GPS or IP address. Many modern systems combine multiple authentication factors to improve the security. Types of authentication. There are several authentication methods used today. Password authentication is the most common but can be vulnerable if weak passwords are used. Biometric authentication uses fingerprints, facial recognition, or iris scans. One-time password or OTP generated a temporary password that expires after a short time. Token-based authentication is commonly used in web applications after a successful login. Certificate-based authentication is used in secure websites and virtual private networks. Two-factor authentication or 2FA combines two authentication factors such as password and an OTP. Multi-factor authentication or MFA combines two or more authentication methods, making it one of the most secure approaches. Authorization. Students often confuse authentication and authorization. So let's explain. Authentication. Authentication identifies who you are. Authorization determines what you are allowed to access. For example, after a student logs into the college portal, authentication verifies the student's identity. Authorization then decides whether the student can view marks, registered courses, or access administrative records. Encryption is one of the most important techniques used to protect information. It converts readable data called plain text into unreadable data called ciphertext. Only someone with the correct key can decrypt the information back into its original form. There are two types of encryption. First one is symmetric encryption and other one is asymmetric encryption. Symmetric encryption uses the same key for the encryption and decryption. It is fast and suitable for large amount of data. Asymmetric encryption uses two different keys, a public key and a private key. It is commonly used in secure communication, online banking, and HTTPS websites. Firewall and antivirus. A firewall acts like a security guard. It monitors network traffic and blocks unauthorized access. An antivirus detects, block and remove malicious software such as viruses, worm, spyware, trojans, and ransomware. Cybersecurity best practices. Cybersecurity best practices are simple habits that help keep our devices and data safe. Some important practices are: use strong password. Create password with letters, numbers, and special characters. Avoid using personal information. Next one is enable multi-factor authentication. It provides an extra layer of security by requiring a second verification method. Then keep software updated. Regular updates fix security weaknesses and protect against new cyber threats. Next one is be careful with email and links. Do not click suspicious links or open attachments from unknown senders because they may contain phishing attacks or malwares. Install antivirus softwares. Antivirus programs detect and remove harmful softwares. Backup important data. Regular backups help recover files if data is lost, damaged, or affected by ransomware. Use secure Wi-Fi. Always use password protected Wi-Fi network, especially when accessing sensitive information. Device security policies. Device security policies are rules that help protect computers, laptops, and smartphones from unauthorized access and cyber threats. Some important policies include password policy. Password policy means use strong, unique passwords and never share them. Screen lock policy, which means lock your device with a PIN or password or fingerprint or face recognition when not in use. Software update policy. Keep the operating system and applications updated. Antivirus policy. Install approved antivirus softwares and perform regular scans. Data backup policies. Backup important files regularly. Access control policy allows only authorized users to access that device and sensitive information. Device usage policy, which means use devices responsibly and avoid installing unauthorized softwares. Explain the fundamental concept of digital device security. Demonstrate an understanding of CIA triad and its significance in cybersecurity. Identify different authentication methods and authorization models. Recognize the role of encryption, firewall, and antivirus software in securing digital systems. Follow cybersecurity best practices to reduce security risk. Use appropriate device security policies to protect digital devices and sensitive information or data.